Hello, everyone. I think we'll go ahead and get started with this session. So hopefully everyone can see these slides okay. So this session today, what we're going to talk about now is it's a continuation of the federated testbeds going beyond fabric discussion that we started yesterday in an earlier session. So I'm Tom Lehman, I'm with the Fabric Project, and today we're going to talk about a couple of different external resources which are connected to Fabric with some ideas about how maybe they can be integrated into Fabric experiments. So one thing I'll just kind of note as an overview is that Fabric has a very rich set of data plane functionality and infrastructure and services. It includes a lot of 100 gig connections, so a lot of DWDM layer 1 connections. It also includes layer 3 routed services and layer 2 connection services. So in addition to that overall infrastructure, there's also a lot of connections to external resources. And sometimes these external resources are networks, sometimes they're facilities at hosting sites. So one of the things we want to talk about is how do we take these external connections, these external resources, and integrate them into experiments? What's the best way from a data plane perspective and a control plane perspective? So we're going to hear some thoughts about that today. So from FIU, we have a site that Fabric site that's planned to be deployed there, and everything's on the way in terms of equipment orders. It's not quite there yet. But Jeronimo Bezerra from FIU will talk about the various connections that are available from that facility. So there's a lot of international networking that FIU and AMPATH and AmLite manages and runs. So we're going to talk about, so Jeronimo will talk kind of what the options are for connecting to those types of resources. Guok from ESnet is also going to talk about some services and infrastructure that ESnet has. ESnet is obviously a very important partner with the Fabric project, and a lot of the connections between the Fabric sites will be across ESnet 6 optical infrastructure. But also ESnet has a lot of work in terms of orchestration services and multi-domain services, so there'll be some discussion from Chin about that. From TAC, Dan Stanzione will talk about the TAC infrastructure, and TAC is one of the early nodes. If you saw the deployment earlier, that's already in service as one of the production nodes on the current infrastructure. So Dan will talk about HPC resources that are connected there and all other types of compute resources. Then Matt Zekaukas from Internet 2 will also talk about some plans we have to interconnect with Internet 2 for both just basic layer 3 BGP type of routing, and layer 2 connection services. But also Internet 2 has a rich set of cloud connect services for public cloud. So there's a lot of questions. What is the best way to facilitate experimenters getting connected to those types of resources? So with that, we'll talk. And there's a question and answer block for people to ask questions. We may answer those questions in line, or we may save them for the end. So please just enter your questions in the Q&A, and we'll figure out the best time to get to those. So with that, we'll get started. We'll just go in the order we see here. And Jeronimo, if I'll stop sharing, you can share your screen.
Thank you, Tom. Let me know once you see my screen, please.
Yes, we see it.
Okay, perfect. Good morning, everyone. Again, my name is Jeronimo Bezerra. I'm here based in Florida International University. I'm one of the co-PIs of the Atlantic Wave STX project. And the goal is to give a quick introduction of what the plans are for the STX in relation to, related to Fabric. So how we're going to be extending Fabric to Florida, Latin America, and Africa. So first, what is the Atlantic Wave STX? For those who don't know, it's a NSF award. It's in its second term right now. The first one, it started in 2015, was a collaboration between FIU and Georgia Tech. So now we're in the second term. This one is a collaboration between FIU, RANSI, USC, ISI, RMP in Brazil, and the Federal University of Rio Grande do Sul in Brazil. So the scope of the Atlantic Wave STX is to create a distributed software-defined exchange that connects all the open exchange points in Latin America and Africa that are part of the AmLite domain to the peers here in the US. So we have, under AmLite, we have AMPATH, that connects South Florida and Atlanta. We have Southern and SAX in Brazil, one in São Paulo, the other one in Fortaleza. We have ENSLite in Chile and Zeaukas in South Africa. And the Atlantic Wave STX had many goals, but I'm just going to be focused on those related to Fabric. And the main one is developing an interface. Since the proposal, the idea was we want to create an API that would enable Fabric and Fabric workflows to allocate resources that are available at those exchange points. So the idea is that Fabric would be able to connect it to the network, instantiate network resources, and instantiate compute and storage resources using the Fabric's chip, their notebooks. Most of those exchange points have compute and storage resources, but we're, as part of the scope of the new project, we're also going to add more resources. There are going to be more 100 gig DTNs, more storage, primarily in Chile, Miami, and Atlanta. We have nodes in Fortaleza as well. And one of the things we want to do is to support bandwidth reservation, network telemetry, and network programmability. So in terms of the network milestones, those are the main ones for this collaboration with Fabric. Is first, we're going to provision a 100 gig optical path between the Fabric nodes in Atlanta and Miami. So this is going to be fully dedicated to Fabric. And we're going to create multiple 100 gig stitch points to make sure that Fabric can connect to our network. So we're going to have stitch points in Atlanta. We have peering with Internet 2 in Jacksonville, and also in Miami, there are multiple networks connected to the empath exchange point, and including the Fabric node. So the Fabric node will have a 100 gig connection all the way to Atlanta, but also we'll have connections to the exchange points to connect to the collaborators and other researchers in Florida. And one of the things we want to enable is per packet telemetry. Since we have in-band network telemetry at MLight, the idea is to give the experimenters per packet telemetry in real time so they can start evaluating how their experiments are running or performing in the shared network infrastructure. So this is a quick diagram just showing how those connections are planned. So we have those green clouds. Those are the Fabric nodes, one in Atlanta, the other one in Florida, in Miami. We have these red arrows, which are the Fabric stitch points where we plan to join and send traffic in and out. We have those yellow clouds. Those are the research and education peers, ESnet, Internet 2. And then we have those blue boxes, which are the SDXs. So there's the SDX in Atlanta. There's two in Florida. There's one in Chile, Brazil, two in Brazil, and one in South Africa. And each one of those SDXs will have different resources available to Fabric. So it could be DTNs, it could be storage, it could be both. All the links will be supporting INT, so because they support it today, so this INT telemetry will be available to the experimenters. And the pink clouds are the Fabric users, let's call it this way. There's University of Miami is mapped. It was one of the use cases for using Fabric. There's the CPTech in Brazil, and there's astronomy projects in Chile also interested in participating in Fabric, and also astronomy projects in South Africa. So this is what I wanted to present, and I'm open for questions. Thank you very much for the opportunity.
Thank you, Ramo. So we appreciate that. If people have questions, just feel free to put them in the question and answer text box. And if not, I think we'll just move along. And the next presentation will be with Chen from ESnet.
All right, can everybody hear me okay?
Yes.
All righty, here we go. So my name is Chen Guok. I work at ESnet. I lead the planning and architecture group, and today I'm going to talk about Sense. And so I understand that today's session is really going beyond Fabric. And so I want to introduce to you, an orchestration platform that we use and have deployed in ESnet, as well as some of the other networks that allows you to essentially extend a layer 2 point-to-point circuit. And so that gives you a larger reach in terms of being able to extend what the Fabric testbed is. So with that, let me go ahead and so this is what Sense is in a nutshell, right? The whole idea when we actually designed this was to actually build an intent-driven multi-domain orchestration framework, and it was really focused towards integrating with the science workflows, right, to be able to manage end-to-end network services as well as site edge data caching. This came out of a DOE-funded project, several years back, and so it's matured to the point where we have deployed this in production in ESnet, essentially the sense architecture is, it's kind of broken up into two discrete components. One is the sense orchestrator, and then the other one is the resource manager. So the orchestrator essentially orchestrates, the resources and understands topology and all that across the different domains, whereas the resource manager is more or less confined to, managing resource within the single domain. So there's this clean delineation of, responsibilities in terms of what each different entity needs to understand. In this diagram, right, you see a single orchestrator. It talks to all the resource managers in different domains. But really, this architecture that we have is, it's reasonably flexible. So we've designed it so that one resource manager can actually talk to multiple orchestrators. And so therefore, the source of truth in terms of your resource allocations is always at the resource manager side. What that also does is it allows you to kind of give different views to different orchestrators depending on what credentials they have. So like in our case, for instance, the LHC folks, tend to, they tend to be heavy users of the transatlantic, and in some cases they actually help finance that. And so we potentially will, provide that topology as part of the information that we update to, say, the LHC orchestrator. But the transatlantic links may be absent from, say, a topology that we submit to, say, the genomics folks, right? And so there's a nice flexibility in terms of how you can actually stack up your orchestrators and your resource managers. Having said that, we've, having this capability in a single domain really doesn't help you much. And so we've been fortunate that we've been able to work with various networks, sites, as well as exchange points to deploy this capability. In a sense, the resource managers are very specific to the domains. And so what we've done is, using the orchestrator, we've been able to adapt the southbound in order to be able to talk to these resource managers. So we support, for instance, in ESnet, we support the OSCAS API as well as the NSI interface, right? On Internet 2, Manland, and Wix, there is the OESS API and also the NSI protocols. For some of the exchange points and other networks, they're using the Open NSA client that essentially is talking NSI. And then we actually have a DTN RM, which is a data transfer node resource manager app that was designed as part of the project that we have deployed at different places. So the DTN RM essentially deals with all the the edge caching cases, right? So the question would be, how can we leverage this for the fabric, right? And there are kind of two ways we can do this. So number one is if you look at requests being initiated from, say, Fabric users, what happens is that the Fabric aggregator manager can actually talk to the Sense orchestrator to look at coordinating resources that are outside of the Fabric topology, right? And the other option is, if there's a request from an external source that wants to use the Fabric resources, then the Sense orchestrator can actually talk to the Fabric orchestrator to kind of coordinate, the provisioning of resources and stuff. This is my last slide. So, again, I think one of the key takeaways for us in terms of how Sense was designed, right, is that, really networking is an end-to-end issue. And so, developing a solution within a domain is great, but having it, consistent across multiple domains, that makes it incredibly powerful. And the other thing that we're seeing too, which I think Fabric has done a great job in addressing, right, is the notion of seamless integration of compute, storage, and networking, right? We're seeing that in these larger workflows that are really complex, that require, the instruments to stream data to supercomputers to do, the visualizations and then take that data and then archive it. Today, it's pretty inefficient because, there's a lot of these partial data movements because they essentially treat the network as a black box. But having this capability where you can kind of integrate everything, we kind of call it a super facility, but other folks have different names for it. But the general idea is seamless integration. So with that, I am done and I'm open to questions.
Okay. Thank you, Chen. I think, yeah, please, if there's any questions, I think at the end we might have a little time left over. We'll maybe have a little discussion and have an opportunity for questions there as well. But why don't we move on next? Dan from TAC will talk about the resources at the TAC facility.
Okay, thanks very much. Audio good?
Yes, audio is good. Yep.
All right, I will get the slides up here in just a sec.
We see your whole screen now at this point. That's okay. There's the slides. Very good.
Okay, you just see slides now?
Yes.
Great, perfect. All right, well, thanks very much for the invite to be here. Good to see many familiar names on the panel. It's actually my second RINCI hosted event this week. I was physically there in Chapel Hill to give a talk on Monday, so which was a very nice change of pace. But yeah, so panel number 3, I think, actually for RINCI this week for me. So, but we're excited to be a part of this, and so I just want to tell you a little bit about how TAC is connected to Fabric and what you can do there. I think many of you know who we are. If you don't, we're one of the big NSF computing centers, so we're where a lot of data ends up and gets generated. You know, those are 2 of our big machines there. Stampede and Frontera are NSF-funded resources that the Fabric node is like physically co-located with. And we're planning a even larger facility down the line in a couple of years in the leadership class computing facility. And so I'm very excited when Ilya reached out a few years ago now to say, you know, would you guys be interested in participating? Because, you know, we're pretty good at the computing stuff, but there's a lot of these end-to-end networking problems like we're just discussed with the Sense platform that, and even though we peered in ESnet and Internet 2, there's a lot of opportunities to do good things. So I figured I should start by saying, yes, we are a node in Fabric, and yes, it is up and running. It's been true for a while now, but this is my first sort of Fabric related talk since the project started, but you can see our node there. And it, you know, pops off the bigger hub in Dallas. TAC is south of Dallas, but, you know, network space, real geography, they don't have anything much to do with each other. But yes, we travel through that learn link there and a little south from Dallas down to where we are. So, but the node is up and running, and, you know, other than bad viz on geography, you can get into our data center. And once you're in our data center, there's a lot of things that you can connect to at, you know, 100 gigabits or greater from that node, and literally a few meters for latency across fibers. You know, Frontera has about 400 gigabits into it, you know, things that you can get to at more than 100 gigabits. You know, has 450,000 cores and a few hundred GPUs. It's about 40 petaflops. Stampede 2 has about 120 gigabits into their data transfer nodes. You know, 6,000 nodes, 400,000 cores. We have Chameleon, which Kate discussed yesterday on a panel, so you get to hear about that, but it's a big and heterogeneous test bed. And some of the hardware sits up in Chicago near their node, and a lot of it sits here at TAC near our node. Those are the big NSF supported ones, but we have a bunch more in Lone Star and Longhorn's more AI. Some storage platforms like Corral that has 40 petabytes of data collections we share via the web. Ranch is our pushing towards an exabyte archive, and there's Kubernetes and VM machines and various and sundry other sort of experimental things if you want crazy ARMs or FPGAs and stuff like that. So, so there's lots of things that are very close to this. They can be data sinks or data sources as you do some of your work. And so, you know, why it matters for us. So just, you know, we happen to be doing some fairly large jobs this week. So that one user could do this isn't typical. But yesterday between noon and 6, I had a user generate half a petabyte of data on Frontera. So in 6 hours, in roughly 500 files, but 500 million 1 meg stripes to screw with your IO systems. We move tens of terabytes out, both in and out every single day at this point. Our typical network utilization, and by the way, if you filter out all the Internet 2 to public internet filtering coming in and out of Texas, where 60% of the research traffic via Internet 2 in and out of Texas ends up at TAC. But our typical utilization is about 30 gigabits per second, and our bursts go into the 80 gigabits now with our current 100 gig feeds. We have good transfers that run at about 5 terabytes an hour if you're doing things right and the wind's at your back and you know how to, you have a reasonable mix of file sizes and stuff like that. But they vary a lot with traffic conditions. We have no good way to do SLAs and quality of service across the network. We certainly could use better diagnostics for the far end, which is where most of the users experience problems. We had a hospital in Houston that involved moving, one Ethernet cable over one port to get a 400 times improvement in performance. And they kept claiming they could get some speed at this until I finally pointed out to their CIO that my $50 a month internet connection to my living room is 30 times better than what they were getting. So, and I was hoping they were paying less than $50 a month, and 12 hours later, the problem was solved. But that's not a good analytics tool to solve that. So that, networking being an end-to-end problem, as the last speaker said, really matters to us. So, for us, big experimental data, both large single instruments and many small edge instruments, seems to matter more every day. Sharing of data sets post-experiment seems to matter more every day. I mean, just this year, just noted it at SC21, this is the HPC-Wire award, we've moved about, 3/4 of a petabyte from Arecibo to, which is obviously not active data, but is a 50-year data set that tons of people want to access. And we're making sure that's preserved sort of in perpetuity here now. I have 8 users who put more than a petabyte of Scratch active right this moment, and all that data needs to go somewhere in the next 15, 20 days. We have, more than 40 petabytes of collections that we share. We have more than 100 petabytes of archive data, and for instance, Design Safe, where we have a few hundred published data sets. People come to the DOI and want to click on the website and download, tens of terabytes and up to 5 million files to get a data set for somebody is not uncommon. And all that stuff works terribly. So we'd like it to work a lot better. So these, and, big instruments, those connections to Chile, through Florida International for Vera Rubin. We were just talking to them this morning. In fact, these flows and being able to manage them are going to just be more and more important to what we do in HPC. So having the Fabric node in our data center and letting us peer it to everything else is awesome. So, there are various tickets and processes you can do to connect to us, but, really the easiest thing to do in almost every situation is just ask somebody who knows. So there's my email address if you want to connect to us, and we're happy to collaborate. Should you need to connect that Fabric node, which is running, Genie and Exogenie experiments and stuff like that now, to one of the other resources, we'd be happy to help facilitate that. So I will stop there. Thanks very much.
All right, great. Thank you very much, Dan. So why don't we just, that's great. Yeah. So why don't we'll just keep moving along. And I think Matt is next from Internet 2.
Yes, thank you. Let me get this going here. All right, and there we go. So I'm going to talk about dedicated connections that are being installed to Internet 2, principally for getting to commercial cloud providers. But you could use them also to get to institutions, or R&E institutions anyway, around the world on over IPv6. And also, you could also get layer 2 connections directly to other institutions, at least in the US. So the commercial cloud, there are 2 basic ways to get to the commercial cloud through Internet 2. One is what we call the Internet 2 Peer Exchange. And I'll talk a little bit more about that, but why are we doing this? Stop. And it's, the Peer Exchange is public peering. Then there's Cloud Connect, and that's private peering. So when you talk about things like, if you've heard of Amazon Direct Connect or Microsoft Express Route or Google Cloud Partner Interconnect, it's the same thing. And a third way is that you could get the same kind of Cloud Connect things, but dedicate to a particular institution. And that's not what we're doing with Fabric, but it's just here for reference. So the IPv6 public address peering, basically, given that Fabric will peer with Internet 2 at IPv6, and I wish I had fixed this, you can get to any of the providers that peer with our public peers. We've got 7 major peering points and over IPv6. So this is standard stuff. So you get to S3 on it, or whatever, you generate your own virtual own cloud resources that have public-facing IPv6 public-facing ports, and it'll show up. So that's what you can do here. We have 8 peering sites. We have, like I mentioned here, it's like 340 gig to AWS, 500 gig to Azure, 600 gig to Google. AWS actually has another 400 gig on our R&E peering. So there's lots of peering to all of these across the major peering sites. And at least AWS, Azure, and Google all peer with us at IPv6. So for the direct connections, this is if you want to have private addresses going to some resources inside one of the cloud providers. Today, it's only Azure, AWS, and Google that do this. But you can use this. You can get up to 5 gig into any of these commercial clouds, and then have it piped directly to your Fabric resources. These aren't really, it's layer 2 in that you have to do a BGP peering over this into your resources within Fabric, but it's still, it's private to you. You can have private IP addresses, and it's like, you can think of data center extensions, or if you want to offload a bunch of data and try to avoid some of the data out charges, you have to figure this out because there's still charges from the providers for these kind of services. But it would give you the opportunity to pull data out that way. It does require Cloud Connect portal credentials, and that's usually through your school or regional. We can probably work something through with Fabric as well, so that you can create these connections. And it will also, you also need cloud credentials, and the cloud providers will, of course, charge you for any connections that you make out. So for Internet 2, what we have is our Cloud Connect portal, which is a version of OESS. It's actually the same software. We've sort of been updating the API so you can connect directly to the cloud. There's this concept of a work group to bound authorization. And so we probably need one per experimenter, or it could be virtual group that's getting together. Fabric, we need to authorize the VLANs on its port to us, and then you can use that to create a connection from that VLAN on that Fabric port over to one of the commercial cloud provider ports. And you connect to the cloud service provider using some credential. Usually it's a service key you get from like Azure or Google, or it's an account number that you give to AWS. And there's you basically have a verification step to make sure that, yes, I want to have this connection, and they'll start charging you for it. The Cloud Connect portal, however, is API driven, although almost all of our current access is through the UI. So you can imagine doing something where you might have a Fabric aggregate manager that talks directly to us, or at a higher level, maybe there's a Jupyter notebook and it has the credentials for the researcher, which has been given access to the portal, and that can create these things on the fly. We have never done that through the Jupyter notebook anyway, as far as I know today. So that'll require some experimentation and documentation. The time to set up one of these things is minutes. So it does not take much time. Usually the longest time is for the cloud service provider to put all their stuff in a row. So you can imagine having something that you keep up for a while and take down so you don't get continually charged by the cloud service provider for this kind of connection. And I just noted here that the connection to the cloud is over our advanced layer 2 service, AL2S, which others have mentioned. And so you could also connect to an experiment to campus, via regional network, or a peer international network as well. Oops, sorry, I hit the wrong button. So just to let you know, we have 4 peering sites that are Cloud Connect enabled, of the 7 or 8 that are just general peering sites. I don't know why it's doing this. Anyway, and we've got the ones that have the most capability are actually Microsoft. They've got 100 gig connections in both the East Coast in Ashburn, which is near Washington, D.C., or San Jose. So that's probably the easiest one if you actually needed to spin something up quickly and tear it down. All the rest of them are multiples of 10 gig connections. We've been working really hard with AWS and hope that they'll move to 100 gigs soon. But right now, I think it's too many commercial folks are asking for them and purchasing them. Anyway, that's what I have to say at the moment. If you've got questions, you can put them up here as part of the end, or you can always send me email, although I get a lot of emails, so if I don't answer you, feel free to send again. And we've gone to the backup slide, so we will stop sharing. I can find my mouse, and then we can go to questions.
Thank you, Matt.
There you go.
This is great. I appreciate this. So I do have a couple of questions, and if others have questions, please go ahead and put them in the Q&A. Looks like we do have a couple of minutes left here. So I think, yeah, this is great. I really appreciate all the presentations. One thing I see two kind of big themes here. One is Fabric's going to have a lot of connections to external resources, external networks, resources at hosting sites, and they're going to be very substantial connections in terms of speed and services capabilities. And also, I think we're hearing a common theme is that when we think about experimenters on Fabric and just in general for people doing domain science workflows out and across other infrastructure, this notion of end-to-end is very important in actually being able to coordinate the resources in a manner that is really tailored to the workflow. So if we look at our session here, title was going beyond Fabric and federating testbeds. So I think all of these infrastructures I've heard about today and others, I feel like that everyone's doing a good job in terms of developing automation systems and APIs and other ways to do automation. Probably on the federating part, maybe we're a little bit further behind in terms of if we think of federation as actually having a normalized view of users from an authentication perspective and authorization perspective, and also from a resource description perspective. I feel like we're in a good position to automate these end-to-end resources for experimenters and researchers, but maybe it's more of an automation than true federation. So I'm just wondering what people think in terms of the resources, how important it is to try to get to the point where we have true federation, or are we going to be okay with kind of doing customized automations to help the users get these end-to-end resources lined up the way they need them? So maybe, I don't know if anyone wants to start off. Maybe, I know, Jeronimo, you've done a lot of work with terms of automating a lot of the international networking infrastructure, and there's a lot of interest into kind of coordinating flows to Chile and other places in South America. Have you thought about how we can integrate all these different APIs and automation systems on behalf of a user?
Honestly, we don't have the full picture yet. What we know is that there have been many efforts to define interfaces between testbeds. And as part of the Atlantic Wave SDX, what we want to do is to support as many interfaces as possible. So I didn't mention Sense, but we are working with Sense. Chin showed that Empath is part of Sense, so is the Atlantic Wave SDX. At this point, we're trying to cover as many APIs as possible. We're working with RMP and Canary, the Canadian Research and Education Network, to support the GreenML, which is a standard way of displaying the topology. So this is what we're pursuing right now. We want to be open to make sure that the researchers, they don't have to change their workflows much to be able to use our resources. And we have this flexibility with this project that we have people that are going to be focused on that. But I don't have a clear answer how this is going to be at the end.
Yes, I think it's a work in progress. Dan, what about for HPC? Have you done much thinking about kind of end-to-end automation and federation for HPC resources?
Yeah, so I'm just going to say that there's sort of three classes of users to think about here, right? So, there's our sort of in-scientific users, right, who just really want networks to work, right? They don't want to think about it. They don't want to do anything to it. So we need, for them, basically, they complain when things are too slow, right? And so at that point, we need to have basically the set of tools that allow us to look at stuff from those of us administering the infrastructure need tools to look at stuff and figure out if there's problems. And if there's not, we need tools to set up channels and service levels and quality of service for those things. So, but that's sort of the end user scientific researcher that we see on, Frontera Stampede. When you look at our Chameleon user base, we have a lot of people who actually care about trying to optimize performance and flows and multi-site stuff. And for them, interacting with a site admin is way too much work because site admins tend to be conservative and they worry about everybody else's problems and they don't really care about everybody else's problems, right? They want to put a VLAN in place between their sites and do something sort of instantly on demand. And they're sort of a special class who need, to sort of live in your DMZ and be able to do things on their own. So but they're a more sophisticated bunch from a computational perspective in some ways. So, so I think we need sort of the tools that site admins need to use to automate things for end users. and they're going to care a lot less about stitching and federation. Just can we make a channel that's fast enough? And fast enough isn't actually as important as consistent enough in terms of their experience. And then can we have a way to get out of that box with the, to put a sandbox around people who actually want to test new and better network services and do multi-site stuff, where they can bypass the site admins. And we have web APIs to a lot of things. We've used OpenStack APIs and Chameleon to automate a lot of the infrastructure things. None of those are quite where we want them to be yet, but that'd be the sort of way to go about it, is integrate with things like OpenStack and Kubernetes for orchestration.
Okay, that's great. I appreciate it. So it looks like we're out of time on the session, so I think what we might have to do is end it so we can go to the next one. I apologize to not get everyone's questions, but if there's other questions for either the Fabric team or for the speakers, please just go to the Slack channel and let's continue the discussion there.